This question involves a circle and some information, but not all the information. So the first thing to notice is that you're given the radius, you're given the chord, and you're interested in the angle. One thing to note here, you might be wondering why this question looks different to yours. Hopefully it looks different to yours. This is from my textbook. Yours may be a newer version. It says show that theta equals 0.739 radians, which gave me pause for a minute. 0.739 radians means less than one radius around the circle. And if the radius is 10 centimeters, then it should have an arc length of 10 lots of 0.739 radians, in other words 7.39 centimeters. Now if the arc length is 7.39 centimeters, there is no way that the shortcut, which is the straight line chord between A and B, is going to be longer than 7.39 centimeters. So it turns out what they're looking for is not theta is 0.739, but cos theta is minus 0.739. Now we've got that out of the way, and you can see that with a negative value for cos theta, that would correspond to an obtuse angle, which makes sense, fits more with what our intuition should be. But you don't need to be extra specially vigilant to notice these things if you follow the standard procedure of draw yourself a diagram every time, especially for things like geometry or mechanics. It's a really, really helpful way of putting all the information in the same place in front of you. Your brain can synthesize it more easily and identify the connections, and the path from the information you have to the information you want is much more obviously, it's practically a physical path through the diagram. We're going to take this thing and move it into here. We're going to use this to generate this, and you can see exactly what's happening when. So this is what the diagram, I've just stolen this from Solution Bank, but this is roughly what your diagram should look like. We care about the sector that it's describing, and specifically the chord, the straight line between A and B. You can think of chord as like a chord of string. If you stretch tightly a piece of string across a circle from one side to the other, then that's what you get here. If you get confused with the terminology, that's going to throw you a bit. So this is the information we have, and generally speaking, for any question like this, you want to be thinking in terms of what am I interested in finding and what should I find first in order to get that. Usually the radius and the angle are the most useful things. Since they're asking you specifically about the angle, that's a good starting point. But the fact that it's asking for cos theta is also a bit of a clue. The reason it wants cos theta is that that's going to be easier for you to find than theta. They're not deliberately trying to complicate things. It's not an additional step along the way of some kind of overly obscure code breaking process. What happens if you try to figure out the value of theta and use the fact that you've got a triangle where you know 3 of the sides and you want the angle, you'll be using cosine rule. The only way a circle comes into this at all is that you need to recognize that we know the lengths of both sides of this triangle that meet in the center of the circle. The key thing about the circle, the thing that all circle theorems are true because of, is that every single line from the center to the edge is the same length. That's the definition of a circle, so you've got the radius there. Once you know they're both 10 centimeters, we can use cosine rule. A squared equals b squared plus c squared minus 2 lots of bc cos capital A. And in this case, the angle capital A is theta, and the side little a is the 18.65. B and C will both be 10 centimeters. So with a bit of careful rearrangement, you should be able to construct exactly what they're asking for. And it's worth checking then that you get a sensible value for theta, even if it didn't then require it for the second part of the question. We can do inverse cos of minus 0.739, and we get 2.40 radians. Remember, this is radians, and we can check that that's sensible. 2.40 radians means 2.4 radiuses around the circle. In other words, if the radius is 10, we should be able to go 2.4 tens around the circle, 24 centimeters. And that will be the curving line here. Now this diagram's not massively accurate. 2.4 radians is more like 140 degrees, something like that. So the angle that we're really dealing with is somewhat more obtuse than it looks here. But still, it gives us a good idea. We're getting an answer which is a bit longer than the chord, which is what we'd expect for the arc when we do that in our heads. Okay, for the next bit, the area of the minor sector. Firstly, when it talks about minor, they're referring to the sector with the smaller of the two possible angles. If you look at the angle between OA and OB, depending on which way round you choose to go, you may get two different angles. If we look for the angle which is no greater than 180 degrees, you're looking at the minor sector. And if you look at the opposite one, you're looking at the major sector. Well, to do this, we just need the area of a sector formula. So again, the terminology is important. Make sure you know what sector refers to. Segment would be a piece which is bounded by an arc and a chord. So it's going to look like a segment of a chocolate orange, for instance. Whereas the sector is cut from the center. So a sector is what you get when you make a pie chart with sectors of an industry, or when you cut up a pizza. So hopefully that gives us a sensible looking answer. And again, we can check that the answer is plausible. If this really had been a right angled triangle, I'd be expecting an area of 10 times 10 divided by 2, roughly. So that would give me about 50. Since it's in reality somewhat wider, and because it also includes all of the extra part, it's not just a triangle, it's the entire sector, then we're expecting a bigger answer. You could even do this the old-fashioned way and say pi r squared gives me the complete area of the entire circle. So pi times 10 squared, we're up to about 300 and something. And then the angle we look at gives us information about what fraction of the circle we're dealing with. 2.4 compared to 6.28 or whatever 2 pi is, well, that's close to a half, but not quite a half, maybe a third of it, something like that. Bit bigger than a third, bit less than a half. And that's what 120 looks like. A bit bigger than a third, bit less than a half of 300 and some square centimeters. So, a couple of quick reminders. The convergent instrumental goal, in other words, the thing which you will usually end up finding because it will generally be helpful no matter what question you happen to be doing. If you're dealing with this topic, you'll be looking for the radius and the angle. You'll either be given them and be able to use them to work things out, or you'll be told other things and you'll need to work out the radius and the angle along the way to finding the things you want, or some combination of those. In this case, you had the radius, you didn't have the angle, and they helped you out by giving you part A, but think about whether you would have seen what to do if they'd asked you for part B. Knowing that there is a convergent instrumental goal, something that would be useful to calculate regardless of what you're being asked for, gives you a much clearer image of what you need to do next in a question. It's a bit like money being the convergent instrumental goal for many different goals and aims you might have in life. We don't chase after money because of what it is, we chase after money because of what we can do with it. And if you're dealing with a radians question, you're probably going to be interested in the radius and the angle for the same reason that you're interested in the first term and the common ratio for a geometric series question. The other thing I mentioned is terminology. Make sure you're clear on what all the words mean. A chord, a sector, a segment, an arc, etc., etc. Major and minor, all those sorts of things. Tangents and normals come in as well to some extent, but mostly with these questions they're talking about the pieces of a circle. And if you're trying to find an arc length or a chord length, remember the answer should be in centimeters or meters because it's a length, whereas if you're looking for the area of a sector or a segment, it'll be in square centimeters. And your standard formulae, these are well worth memorizing, but also make sure they make sense in your head. We can see that the arc length one is just a length, the radius, multiplied by theta, which has no units. It's just a measurement of how many radiuses you've gone around. So this is essentially the definition of radians. The arc length is equal to the radius multiplied by the number of radii that we've gone around the circle. And then half r squared theta is a little more obscure, but it's worth noticing that the derivative of the area with respect to the radius is the arc length. So you can think about why that might be. You can compare it to the derivative of pi r squared becoming 2 pi r, and if in doubt, substitute 2 pi in instead of theta. This is my handiest trick. If you put 2 pi in here instead of theta, you get r times 2 pi. In other words, the arc length, if you go all the way around a circle, is the circumference. If you try it here, half of r squared times 2 pi gives you pi r squared.